Good evening everyone, my name is Petr, as was already mentioned, and I come from Avast Software, and today I would like to present you a tool which is called QA MakeFile. MakeFile is a term which is more associated with the compiler world, but briefly it's a script which helps to build useful and beautiful things. And QA stands for Quality Assurance. It's a department which most developers slightly hate, but we try to do our best to help them. So QA MakeFile is the topic for tonight. Before we start, to set some expectations, I have to warn you, this presentation shall be definitely biased, because I'm one of the developers of this solution, which was developed by my team. During the course of a whole year, so I'm some kind of attached to this and I really like it. Also this presentation, although I talk a lot already around, it will be kind of brief. This solution has a large scale and I will show you just a peek, a small part of it. Also I would like to remind you, and although it scared you at the beginning, that this solution is internal. But those of you with the side see that asterisk, which might indicate it might not be the case always or in the future. What is the purpose of this so far still mysterious QA MakeFile? It has a single purpose to provide a way to store a complete definition of a test, including the environment specification and test action specification in some running system, for example Git. This tool is mostly focused, while it aims to be a general purpose QA tool, it mostly targets quality assurance for desktop solutions, desktop based apps, so the solution is not very suitable, for example, for embedded development or empty devices. This tool is also highly customizable, which is one of the things I would like to show you. So, are you ready for a dissection, for a lesson of anatomy? Let's have a look at a little peek at the infrastructure which supports the MakeFile solution. The MakeFile, as this slide suggests, is some kind of script, as general MakeFile is, but it wouldn't work without the infrastructure support. So this is a really simple ASCII scheme of the things. This MakeFile script talks to a service which, for the purpose of this presentation, I will nickname as the machine provider, and this machine provider talks with another service which I will call simply units. So in case the script needs the environment for the test, the machine, it calls the machine provider. Machine provider asks one of these units, one with the most available, with the most capacity, most free slots for machine. Here I will stop a little. What kind of machine can it handle? Well, almost any kind. In our solution at the moment, it can support solutions based on VirtualBox. There is also an early access solution for VMware, which is a commercial solution, but there are many more options which I will tell more about towards the end of the presentation. And as I already told, this presentation will be brief. It will not cover all this infrastructure. We will focus just on this MakeFile script. And now this promised lesson in anatomy, the dissection. How does this MakeFile look like? It's a simple Python script. And as every good Python script, it starts with the import. Import of the MakeFile module, which is part of the work we did. And the other parts are typically configuration part and execution part. So most of the MakeFiles follow some kind of pattern, some kind of template, and we will have a look more into this. Configuration. In most tools, when you think of configuration, you see some JSON, some YAML, or maybe some evil in file. No, in the case of MakeFile, it's a Python class. Python class which is given magic powers thanks to inherited functionality from the MakeFile configuration. This enables this configuration class to allow specifying the machine setup and the machine actions. And before we dive into the configuration, what about the execution? Execution of the whole configuration is pretty simple, basically one-liner if you are nasty, but I did it on 2 lines. You use the MakeFile run and you reference the configuration specified here. You can also write this setting via command line, you can specify more configurations, but let's stick with the simple example. Configuration. As I said, it has 2 parts, machine setup and machine action setup. So first we start with maybe a little bit of surprise with initialization of axis class or a static member. Axis is the way how we define the environment for the test, and the minimum or the minimum required property of this object is called machines. The machines on which the tests will be later run. Speaking of machines, it's a general term in English, so you can imagine, for example, virtual machines to make it more specific. Machines are specified as a Python list, and this list contains machine objects. The machine object is can consist of 2 parts. First one is some kind of nickname, some kind of human readable name for the machine. The second part is some kind of technical specification. For the most simple cases, the technical specification involves a simple template specification. So the maintainer of your environment prepares some machine in VirtualBox, some image of, for example, Windows, and you can reach it this way. But those of you who can focus on this line can see this. This is a list that it can be made even broader, and it's true. In the most simple case, you are fine with the template, but you can further configure the machine via some stuff we call labels. So, for example, MakeFile template is one kind of label. Another kind of label could be related to some hardware functionality. So I could, for example, specify MakeFile template this Windows 10, and another label would be MakeFile feature hardware acceleration, because not all the templates have maybe the acceleration, and this way you ask for the extra stuff. But for the start, if you want to make simple tests running on 2 operating systems, you are just fine with specifying the name and this template. Machines are the core, but you can extend it. You can add more axes to the test. In this case, let's presume some example of a test which needs to try these 2 operating systems and interact somehow with 2 different browsers. The axis object does not have a browser's members by default, but thanks to the magic of getOther, setOther, we can make it. We can simplify the syntax for people who design these, and you can, after axis dot, you can type anything, for example browsers, but it could be Unicorn, it could be anything, and after that you specify the possible values. Axis, I don't think it does ring a bell at the moment. You can imagine a matrix. Should we have 2 machines, so we can imagine Windows 10 and XPs, and another axis is browsers, which could be Chrome and Firefox. This by default creates a matrix of 4 different machines, like Windows 10 and Chrome, Windows 10 and Firefox, XPs and Chrome, XPs and Firefox. Is it clear, or does it need more explanation? Okay. So I will continue. And once we have this environment set up complete, the specification complete, we get to those actions, right? We split these actions to 3 different types: prepare, test, and post. In theory, there could be a single function listing all these actions, but the advantage is once you review the results later, you can give a different level of severity to failure in the prepare phase and different level of severity if you see a failure in the test phase, because failure in prepare action might indicate some issue on the QA environment, for example, but issue in test actions that needs some alert and maybe some closer examination whether there is some problem with the tested product, for example. You can also see these are functions. These are functions predefined in that base or expected by the configuration. You can specify just prepare actions, you can specify just test actions, just post actions, but in most cases this report is very useful. Each of these functions takes a single value as an input, and that is axis combination, and that means the actual axis combination. If we have 4 machines here, like Windows, all those combinations I mentioned, these functions will get executed 4 times for each combination. And this allows some creativity, some flexibility, as I will try to demonstrate later. To give example now, imagine you want to do some actions on Windows XP and you don't need to do them on Windows 10. Based on this parameter, you can decide later in the body of these functions whether you will do it or not. And speaking of input, we also cannot forget the output. Output is for now some mysterious list. What shall it be? Well, a list of machine actions, as we are in this section. And here we have a real-world example where I do in prepare actions, I copy some text to the machine. Good thing to note is that the MakeFile doesn't presume any specific test framework. You can use a PyUnit test, you can use behave whatever you want, as long as you follow some rules, which I will get to it soon. And in the test phase, I run this script and I collect its result. So if I said that this solution is general, of course there are some rules, some contracts apply. As long as these tests return a standard JUnit XML file, you can get for free a nice result visualization. I will show it. If it doesn't, no problem. You can also use it for another frameworks. To give example, in our company, for example, some of you might know the CCleaner product. They have QA based on C#, so they have compiled pipeline, and they really copy to machine some exe file and execute that. But for example, for another products, there is a Python-based tests which can be used by this as well. So the MakeFile doesn't force you to some specific solution. It's very, very general. And it is also very minimalistic. These machine actions are just a few. There is a copy to machine, there is copy from machine, there is run general command, like in shell, there is a run Python script, which has a benefit that with a further it is out of the scope of this presentation, but this machine action can take as extra parameter, for example, specific Python interpreter if you want to use for some reason. And then we have this collect test result action, which takes that XML output and converts it to something more pleasing for the eyes. So this is a minimal but working MakeFile. You can see it imports module, declares some configuration, and then it gets executed. Maybe some kind of trivia, maybe too easy, but just to wake you up. What do you think is this copy to machine? Is it a function? Is it what is it? What is a machine action? What are these machine actions?
Constructors.
Exactly. Yeah. Perfect. These are just constructors, and it means that at the time you call this function, you don't execute these actions. You just initialize this list. It has the great advantage, one key advantage, because this solution deploys machines and then does something on that. You don't want to deploy machine for some time and then realize you made a typo in file name during the copy to machine, for example. So thanks to this mechanism, it is possible to do formal validation before you deploy anything. Should there be some issue, you will get warned, and then the deployment proceeds further. Okay, so now you just have been exposed to simple first MakeFile. It's time for a live demo, right? Well, almost, because during the preparation I realized that just launching the MakeFile script would reveal some avast secrets regarding the servers, IP addresses, and such stuff. But I will give you like semi-live demo. Imagine this script we just observed will get executed. Nothing fancy, we'll just Python and the name of the script, and then things start to happen. And yeah, before I move to that, some of you maybe noticed that the output of MakeFile run is based on these 2 lines, probably a single number, and that's it. Well, it's not that bad. Of course, this result indicates whether it was successful or not, but you need more detail, right? So what the live part is to show you the real output of running this test. So here I have this MakeFile script called Pyvo. Then here I have some custom script with 2 tests. And what is the main output of the MakeFile execution is this results directory. And this is a real treasure because you have a log of the execution of the MakeFile itself. You have log for each machine, nicely separated for further analysis. Should you download something during the process of the test, you would find it here as well. And for free, automatically you get 2 visualizations. The first one is just a formal view of the execution of the MakeFile. So I will show you how does it look. This is the matrix I was talking about. So here we have our XPs, here we have our Windows 10, here we have our Chrome and Firefox, and here we have some indications. I can click on each of these bubbles and I can see that how did each machine, whether it ran well or not. So Copino machine was a great success, but run Python script not so much. It didn't finish successfully. I can see it at the first sight. I can click for some more details, but this is still some log from the test file I just executed. So for a brief overview, once you see some failed test, for example, integrated in your Jenkins or TeamCity, which is completely easy, it's just Python script. This MakeFile, you can check first this, and if you see, for example, failure during deploy, you know, that was environment. If you see failure during tests, you should, you should be alerted and investigate further. And investigation, speaking of investigating further, as I said, should you, or as long as you use a test framework which supports the JUnit XML output, you get a test result again in this HTML form. I can zoom it a little for you. So here I can see again a slightly different view at the matrix. I can see I launched 2 tests. First one was successful. If I'm lazy, I can click directly show failed test to focus to see just what needs to be fixed, and I can then click on it and get some information. So first I get the summary of the problem. I try to assume that 1 + 1 is 3, which is obviously wrong. And below this I see the whole log of the test, which might be useful for some another analysis. I can also compare here 2 logs from 2 different machines. I can also perform some filtering. So should this matrix be too big, too many axis values, I can also cast here some spells like I'm interested just in Firefox or Chrome, and then just look, this table adjusts, and I can see, I can investigate the problems further and discuss with developers, with the test authors, and such stuff. So this is the output. This is the semi demo, and yes. Speaking of extending, getting back to the code, I said the MakeFile has just a few core actions. But imagine you want to support some new product, you want to add some specific machine action which will, for example, install this product. You can extend it because this solution is Python based, so you have all the tools. You just need to inherit from this machine action, like the prototype for the machine action, and for free. And it expects from you a definition of few methods. It's like interfaces. We use meta classes because we like to use all the Python features. So this way, it's really made sure that you used, for example, the implementation method. For free, you get this internal machine controller magical object, which allows you to interact with the machines on the lower level. You are free to use any. Free to shape the constructor as you want. You can pass any parameters you want and then further process them in the implementation. For free, you inherit the magic of machine actions such as ability to set timeout, timebox the action, ability to set reaction to the failure, and you get also, they will get, thanks to this str override, they will also get nice output in that MakeFile table. So yeah, extending the solution is quite easy. even on the infrastructure level, because as I thought, the MakeFile itself, it's a script, but it needs some infrastructure behind. And imagine you find 5 unused notebooks in your shelf at work, and you would like to use them as test machines. And because you are crazy and because you have a lot of coffee, you can create a custom unit, because the contract between machine provider and the unit is REST API based. So as long as you study REST API, you can plug in another unit to this machine provider and ask for machines from it from the MakeFile script. And because it's REST API, it's just a communication layer. You can write it in any language, but of course Python is the best. And yes, a great surprise. It has documentation, and another surprise. I will show you to it. We are writing documentation right from the beginning of the project, which is incredible, right?
Actually, it's out of date now?
No, it's perfectly maintained, and you can see it's not generated from code, but it really has some like direction behind. So you can read it like a book, getting started, how to install, how to. There is an example of first MakeFile you can copy paste. And there is documentation for the machine actions like reference guide, but then there is, for example, advice how to integrate it to TeamCity, to Jenkins, how to use command line parameters and all the stuff. And yeah, if you like it, this is the only part of MakeFile which is not Python based, because we used a tool which is called MDBook, which is a documentation creation tool for Rust programming language. And yeah, I'm sure Sphinx could do the same job, but we wanted to be cool and we wanted to use the Rust for something, so at least the documentation is there and available. Yes. Okay. And that's all from my side. I just presented you all Python solution. We consider it generic and extendable. Generic for, of course, for certain area of tasks. And the asterisk I mentioned on the second slide, I think, means that we are currently considering this solution for open sourcing. I think we have a good, we made some good steps to make it happen, like having documentation, having unit test coverage of the solution, and being really focused doing the code reviews. So now there is a question to the. I will not conclude this presentation with a dot, but with a question. Do you consider this interesting? Would you consider using it at your workplace? And I'm not trying to sell it to you. We consider to open source it, because that was a slight ambition from the beginning with this solution. Because there are multiple people from multiple different jobs coming to Avast, which created this solution, and most companies we were familiar with need some kind of this solution, so we wanted to create something ultimate and yet easy to develop, because Python is really a pleasant companion development adventure. So what do you think? What are your first impressions?
Why don't you mentioned you want to go open source? You know, a slight branding problem. A couple of decades of MakeFiles. As a build system for either C or other projects.
Yeah, this is completely valid point and something we need to solve, because when my boss approached us and presented us the vision for the project, he said, well, it will be something like a MakeFile, and it kind of stick with the project. So yeah, this is something we should definitely look into and think about some different name. Valid point.
I would say open source it even if no one else wants to use it.
Yeah, definitely.
Yeah.
That shouldn't be a parameter of...
If there's no reason to keep it closed, open source it.
Yeah.
There's always gonna be someone who's gonna use it, so...
I usually do it.
There's not a lot of documentation.
If it's not something like that should remain like company secret, and usually I ask myself, like, can I open source this or not? Just I trying to be critic about it. And like lately I've been doing some automation for Trello, for example, in my team, and this is not like something that we would sell. So I just like open source it.
Yeah.
And not say I have 7% documentation. I'm not that but yeah, the question I have is like, what was missing in, let's say, Jenkins, Travis, or other CI that
Not Jenkins.
tricky, okay, that what was missing in other CI solutions that made you do that?
That's an excellent question. Yeah, we by coincidence we do use Jenkins and we do use the TeamCity. Yeah, these solutions are really great. There's a great amount of work put to this, but they have few disadvantages for us. First one is the thing I mentioned at the beginning. If you have configuration of your test somehow bound to Jenkins, for example, the machine provisioning or to TeamCity, it's not really portable. You want to then maybe change the CI system, and it's a bit of pain because you have to repeat. Oh, I need the exorcist, I guess. So the main benefit, which was appreciated by our users and was wanted by our users, is to take this script and launch it right from this laptop, right from the office computer, deploy the machines from the cloud or even locally on this computer, and iterate quickly on designing the test. I guess that's the most visible benefit, to be able to launch it from your computer, not wait for CI whether there is agent available or something like that, and also the ability to take this complete specification and version it along to your product in the Git. So it's really like system agnostic. It's a Python script, so you can then plug it to TeamCity if you want, but you can still debug it or test directly on your computer. I think these are the two key things, which doesn't seem like much, but they make a difference on the day-to-day development.
When you do that Axis stuff, do you always rebuild the machines? And
I'm sorry?
like the Axis, like that, let's say I have a Windows XP with Chrome and a Windows XP with Firefox, and then do you build the machines on the spot, or do you have some caching system? That I can think of it like, let's say, like a container image.
Yeah, I understand. Well, currently it's being deployed. There are some optimization which allows the deployment to take not more than 20 seconds, which is kind of acceptable. And yeah, so there is no cache. There are the presentation on the infrastructure and the machines. It would be worth another talk, maybe by better and more knowledgeable speaker than I myself. I'm thinking about my colleagues at work now. But yeah, in theory, should this not be okay for you, we can still take this REST API interface and develop something with the cache. But so far the performance is quite okay. You get most of the machines. These machines are like provisioned in parallel. So if you have 10 machines, you get 10 machines posted in parallel. Of course, some of the templates take longer to deploy, but mostly the experience is almost instant, and it's even more supported by the fact you can just launch it from your PC, and you don't have to wait for Jenkins, European queue, or agents. But this is an interesting idea for optimization. It doesn't hurt us too much at the moment, the way information is built. Definitely possible.
So if I don't have the infrastructure set up yet, how easy is it to get started?
If you don't have the infrastructure set up yet, well, you basically need, what are the components which would be need to be open source to make it work? You would need to install the MakeFile module from pip. Imagine we will push it publicly to standard pip. Then you would need to spin some server which will host the machine provider service, and then you would maybe need to spin some server which hosts the unit. Actually, the unit part is already being silently developed at Avast GitHub. It's called Lab Manager, so it's there will be. We plan to prepare a Docker images so the deployment is easy of these supporting services. Yeah. So there should be documentation for that again to make it easy. Okay.
Is the company name related to pirates?
Yes, I think it's Avast is the saying of pirates, and it's not random. I think it's a bit of a language joke from the original authors. It's like it means something like stop. I think so. Avast
Yes, very nice.
virus comes, you say Avast, and it stops and starts to cry. So.
Another little question.
Mhm.
Those pages that you've shown us, where you go through there and you open the logs and everything, are logs embedded into those pages, or are they open from different parts of the file system?
I'm sorry, once again.
You go through the results and you open the logs. for us.
Yes.
Are those logs embedded in the same HTML file, or are they somewhere else on the
Yeah, they are embedded. I don't want to show them too much because they might contain some secrets. So, yes, yes. This is another view at the logs.
We're not gonna tell anyone.
It
It's
was
a whole
on
YouTube
YouTube
yeah.
for me.
I know, so I have to check for it.
So those HTML files are generated by a MakeFile system.
Yeah.
And how does it get the logs to embed into HTML? Is it requested from that unit system?
It is something which I can show. Is basically speaking of the test logs, right? Each of these machines produces this XML file. We have a separated module which is like dependency of this MakeFile, which is just focused on the visualization. And all it does is it takes, because it has the context, the information from the MakeFile script that these machines were deployed and the files are there. These files are there, like this.
How big is it?
It's XML file, so it can get quite nasty, but this is just for these two cases, some kilobytes, but it can get like, I don't know, hundreds of kilobytes maybe for common test.
That's not much.
Common test, but there can be some beast tests. Yeah, but it's XML file and with all of its implications. JUnit XML, I think it's quite known file format. I wish I could open it, but I'm not confident.
So is these log files here, are those embedded into the HTML file? Is this where they come from into that?
There is kind of redundancy. The test log is completely, it's like a flat log from the start of the machine till the end. The XML is the structured view because it structures each log from each test step to a specific tag, and the HTML allows you to look at these snippets by clicking and expanding. So
Yeah,
it's
it's
three level.
the HTML is generated from the XML, so it's
Yeah.
statically written on the
But the XML doesn't contain log files?
Yeah.
Or
The
does it?
important
It
thing.
kind of duplicates them. Yeah. Yeah.
So the XML contains pieces that are already present in my test log, for example.
Yeah. Currently, it's set up in a way that only the info level of log is present in that XML file to not make it really a full duplication. So for the output of the test, it should be sufficient. Should it not be, then you can dive to this hyper detailed log, which contains the most secrets of this presentation. So yeah.
First question, I think it's already answered. You also wrote the machine provider driver machine layer.
I'm sorry?
You have like two layers, the MakeFile and also the machine provider.
Yeah.
The machine provider is also a product from you.
Yeah, a product from our team. Yeah. Especially
Okay,
from two
and
guys.
so the same question that he did, why didn't you use a widely available tool for that? I mean, one of the tools that's already in the market. The first thing that comes to my mind is Docker machine, which has drivers for VirtualBox, LXC, LXD,
Yeah.
Docker.
I understand.
Which I think is one of a big point when if you are planning to open source it, supporting any machine provider, it's like a really
The machine
nice
provider itself, it doesn't have. It's a very simple service because it took a lot of time and design, but at the end it does not do much. What it does is that it accepts the set of labels from the script, and then it searches which unit supports it. So this is like a really thin layer, and this label approach is, I think, quite specific. I don't say that nobody in the world did it this way, but we considered it interesting. We wanted to go with it, and it is quite a simple application. And the units, they are really also again quite lightweight. They basically they are those which really deploy and release the machine, and then we have some service which is like agent sitting on these machines, which the services talk with, or the script talks with, and this is something which was already developed when I joined the company, so we just pick it up. It again does a few things like copy to machine, like these which are exposed to the interface. Why didn't we pick Docker at the time? Docker images. We wanted to. Good question. I don't think it's. We wanted like for, because Docker is not like a full virtualization. We wanted like really assimilated complete operating system.
Yeah, but I mean Docker machine which is capable of spawning, I don't know, virtual box machines, for example, or talking to a cloud provider and spawning machines on AWS.
Okay, and what do you mean by Docker machine? It's like a Dockerized service, or?
It's an application from Docker which can spawn virtual machines. I mean VirtualBox or AWS, or they have like many drivers which can control any cloud provider.
We are aware of the other solution, but we are also passionate developers. So
no, I know, but I think maybe making it compatible to this might help
make sense. Yeah, the adoption and such. Yeah,
so you don't have to spawn, configure your own nodes to spawn machines.
I understand. I will need to look deeper into that. Yeah, thanks for
You
the
wouldn't only
suggestion.
configure that one. Or just you specify what you need, and something probably has to match it anyway. So that is an equivalent to what you mentioned. So they have aware about that.
Yeah, but still good question.
And like when Petr was asking about the infrastructure, and I could picture that for, not nowadays, but companies that I worked in the past. Like we used to do, my first job was for a company writing software for credit card machines. How do you think you would do with embedded devices? And as long as, let's say, it's possible to write an agent, so I could just like have different models of machines, because like we are used to work with like PCs and units and stuff. But then you have some very specific proprietary hardware that you do some work for that, but then you have your application that runs in in different models. Like nowadays, yeah, you have Android that runs in all different smartphones, but imagine if each manufacturer had its own OS and its own thing. You had to compile your application, let's say for Motorola or
Compile, that's a rule to world. All of these solutions are Python based, so no compilation, and that's what makes it easy to port, because even this agent is Python based. So the chance that Python will be supported on this platform is quite high, and if not, then there is some kind of already known contract or interface. But the fact is, our ambition was, let's say, moderate. We didn't really want to solve all the world's problems, but mostly what we do at the work is to deploy virtual machines containing Windows, Linux, and Mac, and should it work stably, that was the first goal. Yeah, it could be challenge. I was not thinking about that far, like mobile support and stuff. I don't know.
Yeah, no, it is. I didn't expect you to be there. I'm just trying to understand, to get a bigger grasp of the motivation behind. Also, like by that, the question I asked before, what was missing in our stuff.
Yeah.
So you basically use this for also like testing Python solutions, or you can also use it for test like stuff in other languages.
Well, we use it to test, for example, Avast, which is definitely or safely or I don't know, not Python based, and it runs okay. The tests are Python based, but yeah.
The tests are Python based, but the application itself is a different language.
Yeah, but for example, yeah, there are other products in Avast which are even not Python automated. The tests are compiled, and yet the MakeFile can be used because it's like a layer. It's like a composer. It's like some kind of a backbone for which orchestrates what will be copied where, and what will be launched. So it can launch binary, it can launch Python. Yeah, we have some more advanced support for Python because we like Python and we use Python, but it's not a block that the tool is written in some other language. And after all, you can still, for example, write a thin layer which will interact with Python, which my colleagues presented multiple times on conferences using the Boost library to make allow control of C++ product from Python.
Yeah, I used to work for a company and we had like
I think it's now just two people talking to
Yeah,
people, so maybe we'll end the formal part of the Pyvo, and you'll be free to interact and ask more questions.
Okay,
Is that okay?